Okay, so this is where we left off last time in the notes about electron configurations. We're going to just finish this up. And so where we left off was that how do electrons go around the nucleus? They go first in a 1s shell, followed by 2s, 2p3s, 3p4s, 3d4p5s, 4d5p6s, 4f5d 6p7s, and so forth. Okay. So S's, reminder, there is going to be one orbital or one line. Actually, I think I can go back in this. So there's going to be one orbital or one line. P's will always have 3. D's will have 5 orbitals. And F's, there's none in this picture, they will have 7. S is 1, P's 3, D has 5, F's have 7. 1, 3, 5, 7, S, P, D, F. Okay, so electron configurations is how electrons are distributed among the various electron orbitals in an atom. And when we write electron configurations, what those things mean, that number in front is a principal quantum number. It's like what shell. It's kind of like before I said, kind of analogy was like, which building are you in? And then S is called the angular momentum quantum number. It's kind of almost like which floor. And then that would be almost like what room, number of electrons in that subshell. So what this thing represents, 1s is the principal quantum number 1. S means L is equal to 0. SPDF, L is equal to 0, 1, 2, 3. And that 1 above, that's written like exponent, is number of electrons in that subshell. Okay, so we write it like this. They also can be done as orbital diagrams or pictures. Sometimes written as boxes or just sometimes lines and arrows. Usually we do up arrow first, then down arrow. So let me go all the way back. So this would be the orbital diagram of neon. Okay, there's 10 electrons in neon. And notice there's 10 arrows total, 5 of them up, 5 of them down. This picture here is the orbital diagram. Written out here is the electron configuration. What does that represent to us? There's 2 electrons in a 1s subshell, 2 electrons in a 2s subshell, and 6 electrons in a 2p subshell. So that's what it means. And S's are spherical shapes. Those P's are those weird dumbbell-looking shapes. That's how those electrons go around the nucleus. Okay, so let's look at a sample question. It says, what is the electron configuration of magnesium? Well, first thing is you have to see where is magnesium on the periodic table. And I believe it's number 12, element number 12 on the periodic table. So how do I know that? You have to look on the periodic table. Atomic number 12. So there's 12 protons, 12 electrons. We're just assuming neutral atoms, not ions right now, for all of them. So 12 protons, 12 electrons. And so what is the order in which they go around the nucleus? They always go in this order until you have 12 electrons. Kind of like here, this thing is 10 electrons, but I want 12. Well, actually, if this is 10, I think I can draw on here. So if this is 10, I want 12 electrons, 10. The 11th one would go, so it'd be an up arrow. And then that's 11. This would be a down arrow, if I can. Okay, that's not a very pretty arrow, but that would be 12 electrons. So electron configuration would be, okay, so electron configuration, how do I just want the writing back. Okay, well, I don't know how to get that writing back. Oh, actually I know. So the electron configuration would be 1s2, 2s2, 2p6, and now we would have 3, oh, because I stopped the pen. And then we would have 3s2. Okay, that's supposed to be a 2. Okay, 3s2. So this would be the electron configuration of magnesium now. That's magnesium. Okay, it's not so easy to write on the screen with a cursor or trackpad. Okay, magnesium's element number 12. 1s2, 2s2, 2p6, 3s2. So so they go in that order. 1s2, 2s2, 2p6, 3s2. There is a shorthand for some of these that we write. We also, to check to make sure this is magnesium, 2 plus 2 plus 6 plus 2 is 12 electrons. This magnesium is also can be abbreviated as this, neon 3s2. Why is it neon 3s2? If you look on a periodic table, you'll notice that this here, that I'm putting in bracket, is neon. That's neon. And so, as a shorthand, especially for really, really big atoms, we write what's called its electron noble gas configuration form. That is, we named a noble gas before it, which is neon, and this is the electron configuration neon, followed by all the stuff that's left. You can't just do it's the element before, but it has to be the noble gas only before. Okay, so noble gas before it, followed by whatever's left. And so this is, you could write the full electron configuration, or this is called the noble gas electron configuration form. Okay, next question here. What are the possible quantum numbers for the outermost electron of chlorine? Okay, the reason why again, neon is 1s2, 2s2, 2p6. Just like what I had in this bracket. So that is neon. Oops, that's supposed to be an equal sign. Okay, I can't draw on the screen. Okay, neon equals 1s2, 2s2, 2p6. Okay, next thing. What are possible quantum numbers for the last or outermost electron of chlorine? Okay, chlorine, if you look on the periodic table, is element number 17. For this chapter, this electron configuration stuff, you need a periodic table. You need to reference a periodic table somewhere. Okay, but it's element number 17. So it always goes in that order. 17 electrons. If you did the electron configuration, it would be this. 1s2, 2s2, 2p6, 3s2, 3p5. To check, 2 plus 2 plus 6 plus 2 plus 5 is 17. Okay? 2 plus 2 plus 6 plus 2 plus 5 is 17. That's 17 electrons. This is electron configuration of chlorine. Okay, so question. What are possible quantum numbers for last outermost electrons? What is the last outermost electrons? It's in that 3p level. Okay, the last electron was added to 3p level. If you drew the arrows, the last arrow would go in the 3p level. 3p means n equals 3. P means L is equal to 1. If L is equal to 1, what are possible values for ML? ML are all the integers from negative L to positive L, or in this case, negative 1 to positive 1. And there's another set of quantum numbers, MS. What are possible values for MS? Plus or minus a half. You don't know which one. It's one of those two. Okay, so the last possible quantum numbers for the last outermost electron of chlorine would be n equals 3, L is equal to 1 because it's in a 3p level. N is equal to 3, P means L is equal to 1. ML could be negative 1, 0, or 1. MS could be positive or minus a half. Okay, I like this way of determining electron configurations. This diagram is in the book, but it's also, you'll see it throughout everywhere. This is our periodic table and where those electrons configurations go. So as electrons go around the nucleus, they always go in a 1s shell, followed by 2s, then 2p, then 3s, then 3p, then 4s, 3d, 4p, 5s, 4d, 5p, and so forth. So when I said before, like, oh, I'm going to go all the way back. Here. Oops, I just passed it. I said, oh, the electrons fill in 1s followed by 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. It's like, oh, do I have to remember this? No, it's easier if I just remember it this way. This is the S areas. P's are here in the green area. D's are here. The transition metals are D. And these lower levels, also known as intertransition metals, are S down here. It goes 1s followed by 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s. After 6s is actually not 5d, it's 4f. Because if you look, I don't have a periodic table in front of me. After this element here in the periodic table, it is lanthanum, which is down here. And then we go over here to 5d, 6p, 7s. And then it jumps down here. So these 4f, 5f actually should be cut and put into the periodic table between 4, 6s, 5d, 7s, 6d. They should fit in here. The reason why they're put down here is to get it to fit on a single piece of paper. It's kind of like sometimes you have a map of the United States and you have Alaska and Hawaii cut off and just put underneath like Florida or underneath California. That's not where they are. It's just to fit it on the map on a single piece of paper. We cut it out, shrink the size of Alaska as well because Alaska is huge, and shove it in a corner. Okay, that's what 4F and 5F are. They should actually go here, but we just cut them out and stick them down there to fit on the paper. Okay, so now we know the order in which they go in. Let's look at that last magnesium example here. Magnesium's 12 electrons. Magnesium on a periodic table is... Where's magnesium on a periodic table? Since I don't have one in front of me. Okay, it's actually right here on the periodic table. If you grab the periodic table and you looked at magnesium, it's right there. So it's a second one in 3s. That's why it ends in 3s2. What's before 3s2? What's 3s? It's 2p. And how many atoms are in there? If you count, there would be 1, 2, 3, 4, 5, 6. There are 6 atoms or 6 elements in the 2p level. That's how it would be 2p6. What's before 2p6? Before 2p6 is 2s. And there are 2 elements in the 2s level. Before 2s is 1s. And there are 2 elements. And there are 2 elements in 1s. So the electron configuration of magnesium 1s2, 2s2, 2p6, 3s2, 1s has 2, 2s has 2 elements, 2p level, if you count it in the periodic table in front of you, there'll be 6, 3s level will have 2. So what is after 3s2? It would be 3p element. First one would be element number 1, 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. Followed by 4s1, 4s2. Then it'll go 3d1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in the 3d level, followed by 4p, 1, 2, 3, 4, 5, 6. So this is just an easier way to determine electron configurations. I kind of just look at a periodic table. It's faster for me. So this is just another way. If you want the electron configuration of all elements, here they are, up to 108. Okay, here are the electron configuration of the first 108 elements on the periodic table. Okay, so yeah, so that's pretty much it for now, and we'll just pause from here.